Alright, what is up guys? Today I'm going to talk about question 85 on LeetCode. So here we're given um, a quality and a wage array for each worker, and we're also given a number k, which is the amount of workers that we need. And the goal is to find out the least amount of money needed to pay a group of k workers to satisfy these two conditions, which is we need to pay at least the minimum wage, and also each worker is paid by the ratio of the quality array. So for example, if we want to hire worker 1 and 3, that means we have a total of 15 units of quality, and worker 1 will get 15 out of 10 of all the money, and worker 2 will only get 5 out of 15 of all the money. And also we know that for worker 1 we need at least $7 per unit to meet the minimum wage, and for worker, actually it's 3 here, we need at least we get this 7 is because we have we need $70 per 10 unit. That will give us 7. And for worker 3 we need at least how we calculate it? So we $30 per 5 unit, that will give us 6. So we need $6 per unit of quality. That means we need to pay everyone at least $7 per unit if we want to hire worker 1 and 3 to satisfy the minimum wage requirement and also the ratio requirement. So so we need the bigger ratio, the bigger unit price. So from this we know that the bigger unit price will give us will be the unit price that we're going to use for all the workers. And yeah, and also so the idea for this algorithm is to first we calculate the ratio for each worker. So here we will have worker, we'll have an array of ratio, which is the first is 7, and then the second is 50 over 20 will give us 2.5. 50 over 20 give us 2.5, and then 6. So this is the ratio for worker 1, 2, and 3. And we want to sort this by its ratio from least to the greatest, because we want to minimize the price, the amount of money that we pay to the workers. So we want to start from the minimum number of money that we need to pay, the unit price. So if we want to store this, the ratio will have 2.5, 6, and 7, and this will correspond to worker 1, 3, and worker 1. Okay. And cool. And how do we calculate how much money we need to pay for any two particular worker? We can do that by okay, so let's do some notes here. So this is worker, and then here the first row is worker, the second row is unit price. Let's say unit $sign, and the last column, that's right, that's it. Cool. How do we calculate any two given particular workers? If you want to hire a worker, hire 2 and 3, how do we calculate how much money we need? First, we need to find the bigger of the unit price, and then we need to find out, yeah, okay, we do need the third column, which is quality. The unit worker 2 will have a quality of 5. Actually, not 5. Worker 2, 1, 2, 3. Worker 2 will have a 20, and worker 3 5, and worker 1 is 10. All right, cool. So for worker 2 and 3, we know that we need to pay everyone at least unit price of 6, and because they have a total quality of 25, so we know 25 times the unit price of 6 will give us 5 times 6, 150. Is that right? 25 times 6. Yep, 150. And let me use a different color. If I want to hire worker 2 and 1, that means we need to find the minimum, the maximum of the unit price, which is 7, and their unit price combined will be 30, so that will give us 21. Okay, what if I want to hire worker 3 and 1, and we want to find a larger one of the unit price, which is 7 again, and we also want to find the sum of the quality, so which is 10 plus 5 give us 15, so 7 times 15 is 105. Okay, so as we can see, we have tried every worker combination because our k is equal to 2, and we can see that the least amount of money we can pay is 105 to hire worker 3 and 1 which is the solution. So as you can see here, so each time, if we iterate through this this array of workers sorted like such, I mean like this unit price here, we can use a max heap to keep track of the most expensive worker by unit, and each time max heap, and if the heap reach a size of k, has size of k, that we know we have cumulative k workers, and we can also have a global variable that keep tracks of the total units that we've encountered so far, and each iteration we just get rid of the most expensive worker. So we include the current worker and we get rid of the most expensive worker, and we'll calculate a new total unit price. And then if everything is sorted by its unit price, we know that that iteration, that unit price will be the unit price for every worker that had every worker that we're using, and every worker that we're using will have a total unit price calculated already. So we just need to have this total unit price times a unit on that iteration. That will give us the solution. All right, so let me code this. All right, I think we're recording. Okay, so let me code this up. So like I said, we will need a priority queue. That will have integers. That inside the priority queue, collections.reverse order, because we want a max heap. And then we want to have an array of workers. First let me get a dimension. So here we'll have a size n of 2, and for each worker. So here we're just populating the workers array. So workers I will be equal to new int array of quality and wage. Okay. And now we want to sort it based on its unit price. So we're going to sort workers and give a comparator. Unit price, so we want to have A quality, which is 0, divided by A1, and B quality divided 1 second. I think it's the other way around, so it's 1 divided by B0. And yeah, this as well. This should be the wage divided by its the number of qualities. Okay, so now once it's sorted, we can start iterating all the workers. Okay, so here we need 2 variables. So first is the double of solution, and because we want to find a minimum, so we can assign it to max value for now. Max value, and also we need a variable to keep track of the total units that we have seen so far. So on each iteration, we'll update the total unit to worker 0, which is quality. So, and then we want to add that to my priority queue. And then if my priority queue is greater than my size k, that means my total unit needs to decrease by the most expensive, the worker that's gonna take the most amount of unit of qualities. So that will be minus that, and also right, I think that's it. And if my size is equal to k, that means we have right amount of workers, and we need to update the solution. So there's a chance that it is still minimum, or we can calculate the new minimum, which is total units times this workers unit price. That's wage, which is worker 1 divided by worker 0. Okay. And we just return my solution. Okay, let's see if this will work. All right, perfect. Submit. All right. There's obviously some optimizations that we can use. For example, we can make a worker object, or increase the dimension by 1 and store the unit price in place, so we don't need to calculate every time. And the time complexity, because we're using sort, that will be n log n. And the space complexity is basically this worker array, which is log n. Not log n, of n. All right, thank you for watching.